Why, hello. Let's talk about fractions. And boy, excuse me, boy, I'm starting off with a cough already. There's a lot to talk about here, folks. So I'm going to have a little bit of coffee before I begin. A little sip of, that is delicious. There's a lot to go over, and I don't expect for us to take notes on every single thing that we do at first, because some of the stuff we maybe have taken notes on and some of the stuff we have not. You are welcome to take notes from the very beginning if you want to right now, but I'll definitely let you know if we've already taken a lot of notes on certain stuff. I'll say, hey, like start now, start taking notes now. Okay, so up until then, let's just kind of go for it. Okay, we're going to start at the very, very beginning of the process. This is called a tape diagram because it looks like a piece of tape. Okay, and this is how fractions are typically represented. Okay, there is one rectangle that represents one. It represents the whole, W-H-O-L-E. That means the entire thing, one piece of something. And that one piece of something is broken into smaller equal pieces. Equal is really important. I know that my drawings are not perfect, but ideally this piece, this piece, this piece, and this piece should all be exactly the same size and shape. I know they're not, but they're supposed to be. Okay, so let's talk about fraction 101. Okay, the bottom number of a fraction is how many pieces there are in all, shaded and unshaded, all of them. That's what the bottom number should be. And we say this in a very special way. We don't say fours, we say fourths with a T-H-S. Well, usually for most of the numbers, we go th afterwards. The top number is what is being named. Now, usually the 90% of the time, it's how much is shaded in. Sometimes they will ask you what fraction is not shaded in, which, by the way, would be the same exact answer for this one anyways. So the top number is how many are being named. Usually that's how many are shaded. And the bottom number is how many there are in all. Now, it gets a little complicated when you have a tape diagram that looks like this. This one, you'll notice what I call the circus top extends all the way across, which means this entire thing is one whole piece. This is the entire thing. But for this example right here, it does not go all the way across. This right here is the whole piece, W-H-O-L-E. And these are extra pieces. So even though there are a total of 6, the bottom number, what we call a denominator, is not going to be a 6. Because the circus tent only goes this far. This is 1/4, that's 1/4, that is, and believe it or not, that's 1/4, and that is 1/4. So really the bottom is going to be fourths. Okay, they're all 1/4 pieces. Okay, and since they're all shaded in, and there are 6 of them, the top number is going to be a 6. This is what we call a greater than 1 fraction, because if this wasn't here, we would have no idea that was like, we wouldn't know what to do. But since this tells us that there's a hidden 1 inside, it's actually, the top number is going to be larger than the bottom. 6/4, because every one of these is 1/4. Okay, so from there, we go into decomposing fractions. Decomposing is actually pretty simple. It's breaking a fraction down into smaller fractions. And so all you really have to do is take this top number and come up with some ways to make 5. Okay? Like, for example, 3 plus 2. Now, the bottom number always stays the same. So if this is a 7th, then that's a 7th. If this is a 7th, then that's a 7th. So you can easily break down 5/7 into 3/7 plus 2/7, because 3 plus 2 is 5. We never add the bottom numbers. No, ma'am, no, sir. We never do that. So 3 plus 2 is 5. Now, there's other ways we can break it down, though. Is that the only way? What about 4 plus 1? 4/7 plus, yeah, plus 1/7. We could do that. Now, what about breaking it down into unit fractions? Now, this is another term that you need to know. A unit fraction is when the top number is a 1. Okay? 1 plus 1 plus 1 plus 1 plus 1 is 5. And all of these are going to be 7ths. 1, 2, 3, 4, 5. Circle, 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 circle. Doop, 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 doop. This is called by the way, this is called a number bond. Probably should have mentioned that. This is called a number bond, and you've probably seen this before if you do the program Zern. They're very fond of number bonds. So you can break this down in a few different ways. There's more than one way to peel an onion. And so this is a possibility for decomposing 5/7. This is a possibility, 4/7 plus 1/7. There's lots of, you have different choices. Okay, so again, remember this term, unit fractions. It means there's a 1 on the top. And unit fractions can come in all sorts of different shapes and sizes. 1/8, 1/100, 1/25. It doesn't matter. As long as there's a 1 on the top, that's called a unit fraction. What is it called? You heard me. Now, let's get into showing decomposing in a different way. Again, so far, we pretty much should have notes on all this stuff. We really kind of should. So we know that this is called a circus tent. It shows us that this entire thing is 1. This fraction is, will you tell me, what is this fraction? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It's 4/6. Okay? Now, we're going to show the decomposing by putting little tiny upside down circus tents right down here. And again, we have lots of different choices. We could do 1, 2, 3, 4 different little circus tents, and it could be 1/6 plus 1/6 plus 1/6 plus 1/6. Or we could do a simple 2 plus 2. Again, we have lots of different choices. You could have done 3 plus 1. Lots of different ways you could have done this. But what is important is that we label things. There's 2 out of 6. There's 2 out of 6. Okay? 4/6 equals 2/6 plus 2/6. Okay? And that's it, right? And again, as I said before, you have many, many different choices. Okay? Sometimes, though, they'll give you the opposite. They'll give you the number sentence, and you have to make the drawing. Now, I can't promise this is going to be really great, but let's see what I can do. If I want to make something into fifths, how many lines should I put? That's right. Believe it or not, 4. It's always 1 less than the amount of space you want to create. Oh, let's see if I can do this. 1, 2, 3. Not bad. Okay. So 4 lines to create fifths. Yes. And you would want to shade in 2. You don't have to be super, it's fine. Good enough. Good enough. Okay. Oops, wait a minute. That's 4. I got to shade in 4. I was looking at that fraction. Come on, Mr. Brown. Really? Shade in 4/5, Mr. Brown. Not 2. 4/5, not 2/5. So anyways, now should there be a circus top on this? Probably. And should you represent this? Yeah, that's not too hard to do. So again, it's kind of like what we just did up here. I'm not saying, I'm just saying. You know what I mean? Maybe I should have chosen maybe I should have chosen something a little more interesting rather than, you know what I mean? Come on. That's what we just did. How about like a 1 and a 3? How about a 1 and a 1 and a 1 and a 1? Again, like I said, we have many different choices. So let's make it interesting. 1/5, 3/5. And this is all you got to do. Make sure you label. Okay? So this is decomposing when they give you the picture and you fill in the numbers. And then sometimes they give you the numbers and you draw the pictures. Okay? But it's all good. What do we have next? Oh, we have equivalent fractions. Now, this is where you might want to start taking notes. This is where Mr. Brown might take another sip of coffee. Because we did take notes on this, but I don't know if they're in their notebooks or sometimes in a separate loose sheet of paper that you took home. So you might this might be a situation where you might want to start taking those notes if you haven't already taken. Okay, so if you haven't, open up to your next Fresh Clean page and let's start crack-a-lacking. Okay, you can show equivalent fractions in different ways. Okay, you start off by making this, and yes, I want you to do this. Okay. And let's say we'll just shade in one piece. What fraction is being shaded? Yeah, it's 1/4. right? This is 1/4 right here, 1/4. Now we're gonna do, sometimes this is a weird part because this is when we stop doing giant circus tents. We're just going to assume that this is all 1 because we already have a circus tent on top. You see what I'm saying? So it's like we don't want a circus tent on top of a circus tent. So this is why sometimes we just do that one. Now check this out, gang. There's 2 different ways that we can break this up into smaller pieces. And we use the dashy lines to do it. We can either do the dashy lines up and down inside of each piece. And if we wanted to make our lives simple, we would just do 1 set of dashy lines inside of each. So where it used to be 1, it's now 2. See? So now when we used to have 1 shaded bit, now if we look at just this piece right here, we have 1 out of, well, how many now? Oh, now there's 8 pieces. And there's another 1/8. So in this example, we're breaking them down into unit fractions. Unit fractions, okay? 1/8 plus 1/8. So we're breaking these down. So again, where the 8 come from? There used to be 4 pieces. Now we've made 8 pieces because of the dotted lines. Used to be 1 piece shaded in. Then we added the dashy lines. Well, we still have 1, but look how it's smaller. What we've actually made here is 2/8. 1/4 is equal to 2/8. And we've just shown that, how that is right there. Okay? Now, another way that we can do this is to do dashy lines that go all the way across. Okay? So let's imagine again, we'll keep it simple. Keep it simple. Okay? We'll just shade in 1 piece. This is fifths, right? I added 4, 1, 2, 3, 4, 5. This is 1/5 right here. Now, if we added dashy lines going across, we can break them up in a different way. So let's do 2 dashy lines going all the way. Boy, this is going to be kind of, it's kind of weird with, oh, this is so, first of all, it's so sloppy. And second of all, these blue lines are messing me up. These blue lines are messing me up. So whereas we used to have 1 piece, we now have 3. Notice how we're not breaking it down into unit fractions like we did up here. And where we used to have 5 pieces, 1, 2, 3, 4, 5, we now have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it's 3 out of 15. We represent them both at the same time. Okay? 1/5 equals 3/15. And we can prove that's true if we put tiny little multiplication signs and we multiply the top and the bottom both by 3. Oh yeah, that's true. Okay, that's true. One more thing. Boy, this is a long video, I'm sorry, but we've covered a lot. We've covered a lot so far. We've covered a lot. This is a GTO, it's a greater than 1, right? I know this is a lot. I know this is, you want me to draw this? Yeah, I know. But most of this video I've just been yabbing. I haven't asked you to draw stuff until just recently, so it's okay. This is a GTO of 7/4. Here's one thing that I really want us to, this is something we have not talked about very much, and we really should. You can represent this as a multiplication fact of 7 times 1/4. There are 7 pieces, and each of them is a 1/4 piece. We know that because this is the whole. WHOLE. This is 1/4, 1/4, 1/4, 1/4. Hey, that's 1/4, 1/4, 1/4. There are 7 1/4s. 7 times 1/4 is the GTO 7/4. How can that be the case? Because you can take any whole number and represent it as a fraction by putting it over 1. What? You're blowing my mind. It's true. You can take any whole number, put it over 1, and it's a fraction. It's a weird fraction, but it's a fraction. 7 times 1 is 7. 1 times 4 is 4. So you could do this and see, like, here's some other examples. 5 times 1/2 is 5/2. 8 times 1/6 is 8/6. You can represent these as, you can represent this. It's kind of an unusual thing, right? We're not used to mixing whole numbers and fractions, but this is how it works. Now you try. Okay? Now this is supposed to go over to here, so I apologize for my sloppy writing. This is not the greatest circus top I've ever made in my life. I want you, okay, to make this. I know this is taking a while. Please, thank you for your patience. And I want you to represent this as a multiplication sentence. A certain whole number times a fraction, what each one of these is, equals a GTO. Whole number times each unit fraction equals what is it in all. Just like we did here, just like we did here, just like we did here. Use this as a guide. Okay? And do this. And then you'll be all set. All right? Thank you very much. Holy moly, that was a long video. And that's okay. It needed to be. It needed to be. It needed to be a long video because it was a lot we went over. And I thank you for your patience. So have an absolutely fantastically, wonderfully amazing day. And I will see you. Bye-bye.